Hi, this is David. I once read that discount factors do not lie, and I really like that. Let me show you why. If we take a $100 face value bond that pays a 6% semi-annual coupon, and I'm just going to assume the coupon, this bond rather, matures in 2 years, then we've got $3 coupons every 6 months until maturity at 2 years. That's the $3 coupon plus the face value, also called the par or principal. So this is the future stream of cash flows. Here's my timeline. And then just as an input assumption, I'm going to assume a spot rate curve. So that's a curve of observed spot rates. So denoted here by R, not atypical. Sometimes that's denoted with an S or a Z. And that's because they can also be called spot rates or zero rates if we extract them from asset prices. So those are key. Those are what we would observe in the marketplace. And then here's my discount factors. So if I want to do this discount factor for 1.5 years, for example, I just take 1 divided by 1 plus my 1.5 year spot rate or zero rate. And this is semi-annual compounding. So I'm going to divide by 2 and then raise it similarly by the 1.5 years multiplied by 2. So divide by 2 here is consistent with multiply by 2 here under a semi-annual compound frequency assumption. And that gives me my discount factor at 1.5 years, and here's my discount factor at 2 years. So each horizon here, each time horizon, has a discount factor, and the set of those is the discount function. And so why do we say discount factors do not lie? Well, that's because we don't need to worry about the implicit compound frequency assumption. We just use the discount factor as it is. It embeds the information of the compound frequency. So it's really the most concrete thing we can use, the discount factors. So to use them, we just take the future cash flow, multiply it by the discount factor, gives us the present value. So that's the present value of the 2-year cash flow. And I get the present value of each cash flows. Again, just the future cash flow multiplied by the discount factor. See how what we really want is the discount factor. And then you may know if we sum the stream of present valued cash flows, then we get the theoretical price of the bond, in this case $108.66. So the discount factor does not lie. And just to highlight why that's important, this 1.60%, if we just see that as a per annum rate, it's actually ambiguous because we need to know that it's with semi-annual compound frequency. The equivalent annual rate to that is 1.606%. Here's the equivalent quarterly rate, and here is the equivalent per annum rate with continuous compounding. All of these have the same discount factor and really are the same rate. But you can see we wouldn't know that unless it's specified. So just to highlight that, if I have this 1.597 as the per annum interest rate with quarterly compound frequency, then I would convert that into the discount factor by taking 1 divided by 1 plus that rate, divided by 4 because it's 4 periods per year under quarterly, and then to be consistent, I'm going to take that 2 years and multiply by 4. And I should get the discount factor for 2 years and see how it matches. Similarly, if I come down to continuous and I know that I have a 1.594% interest rate per annum with continuous compounding, then my discount factor is going to be the exponential of -2, the rate here, times the 2 years. And I get the same discount factor. So you can see how the discount factor, unlike these zero spot rates or zero rates that we're a little more familiar with sometimes, this discount factor is never going to lie to me, or in other words, always going to include the information of the compound frequency. So this is David of the Bionic Turtle. Thanks a lot.